Okay, so lesson 6, linear scale factor and how it compares to area. So sometimes people will say like, well, I want the area to be twice as big, or I want the area to be 10 times as big. And then the question is, how does that relate to scale factor? So let's take a look at this investigation. You're going to go through this chart with me, and we'll start with the first one. And it goes, the length and width of a rectangle are 3 and 5 respectively. Okay, so we are up top left here. 3 by 5. 3 is the length, 5 is the width. They have you calculate the area. The area of a rectangle is straightforward as length multiplied by width. So clearly 3 times 5, 15. So the next chart is, or the next column, is linear scale factor. So that means that you have to use the scale factor to change each dimension separately. So the 3 becomes 6 because the scale factor is 2 to 1, or 2. 2 over 1 is 2. So it's doubling. You're doubling. Okay? So what do you think is going to happen to the 5? 5 will become 10. Now they ask you to calculate the new area, which is also length times width, just with the new values. So compare the two areas. Here's 15 and here's 60. What they ask you to do is do a scale factor for area. Take the new thing and divide the old thing, but for area. 60 divided by 15 reduces to 4 to 1, which is just 4. And then I'll put in red pen what you're trying to compare. Compare the linear scale factor to the area scale factor. For the one dimension, it's 2, but for the 2 dimension, it's 4. And let's just keep going through this chart, and hopefully you spot the pattern. Okay, 9 times 6, the first area is 45. The linear scale factor is 1 to 3. You can see that the first number is smaller than the second number, so this is a reduction. So you need to multiply by 1/3. Multiplying by 1/3 is the same thing as dividing by 3. Thank you. So we need to take 9 and 6 and scale them by 1/3. So what does 9 become? Good. Divide by 3, or times by 1/3. What does 6 become? That new area is 6. Put 6, the new thing, on top of the old thing. And then that's 6 and 54. I'm going to want you to put that in your calculator with math fraction. And you get, of course, 1/9. Compare the original scale factor for the linear to the area scale factor. 1 becomes 1, 3 becomes 9. How's that related? Did you have a question or a comment? Sure. Absolutely. Okay, well, let's just keep going. Maybe you guys don't spot the pattern yet. 4 times 8? 4 times 8? Did I get that one correct this time? Don't even know my own times tables. Okay, so now the scale factor is 3/2. What's the decimal for 3/2? 1.5. So I need to take each one of these dimensions and times by 1.5. So you take 4, times it by 1.5, you get 6. Take 8 and times it by 1.5, you get 12. What's 6 times 12? 72. Okay, new area, 72 over old area, 32. Now when you do that 72 over 32, use the calculator and do math fraction. 9 over 4, good. So I'll just show it to you one more time. What are the numbers? 72 divided by 32? And then that 2.25 doesn't tell you much, but if you go math fraction enter, you get this 9/4. That 9/4 tells you a little bit more information. This 9/4. Okay. Compare the 3/2 to the 9/4. 3 becomes 9 and 2 becomes 4. What's happening? What's the comparison between linear to area scale factor? Times by themselves. Beautiful. What does it mean to be times by yourself? X times x is x squared. Does it make sense that area would have a square and a dimension 2? Yeah, okay, perfect. We're there. You guys see it now. 3 times 12 is 36. You got to multiply by 2/3. So when you do that, I'll put it on the whiteboard. When you do that, I'll go over here. 3 multiplied by 2/3. That's how you can put it in the calculator. And then the other one would be 12 multiplied by 2/3. What do you get? 2 by 8? 2 by 8. 2 times 8 is 16. 36 over 16. Reduce that to a lowest terms fraction and you get 16 over 30. Oh, I got it backwards. Thank you. The new one over the old one. Thank you. 16 over 36 and you get 4 over 9. Did it work? 3 became 9. 2 became 4. So now you can complete this formula. Area scale factor equals linear scale factor squared. And then I'll show you how simple this actually is when we do the homework problems. It's essentially just the linear scale factor squared. Okay? So let's talk about this 8 by 10 photograph. An 8 by 10 photograph, this is like maybe at your house on your dresser. Maybe you have a framed picture of your best friend. 8 by 10 photograph. Okay? This guy, Maggie, this girl, wants to increase the size by 44%. Highlight increase, highlight 44%, and highlight area. When you are increasing and decreasing by percentages, follow this pattern. 100%. If we're increasing, what operation should we use? Plus. And then the 44% goes here for 144%, which is what decimal? 1.44. Is 1.44 greater than 1? That would be an enlargement, which is what she wants to do. Okay, so that is your scale factor, 1.44. All right, this is how I'd want you to write this. k squared is equal to 1.44 because they said that we want to increase the area by 44%. So because it says area, k squared is 1.44. We can square root both sides, and you can get that k is 1.2. But the book has picked some nice numbers that work out well. Explain why these two factors are different. Well, the 1.44 is for area, and the 1.2 is for length. Okay, so it has to do with dimension. One is two-dimensional and the other is one-dimensional. So to determine the dimensions of the enlarged photograph, you have options. Okay, you can start by taking the original dimensions, 8 inches, and timesing them each by 1.2. Okay. And I'll bring that down here. You would get 9.6 by 12. Or you can take the area. What's the area? Area of the original. It's an 8 by 10 photograph, 8 on the length, 10 on the width. 8 by 10 is 80. You can take that 80 and times it by the area scale factor, which is 1.44. 80 times 1.44 will give you the 115.2 square inches. You can double check that multiplication. If you were to multiply this, you would also get the 115.2 square inches. Okay, let's talk about linear and area scale factor by just keeping it simple. Let's draw like a 2 by 3 rectangle. After this, I hope this is quite clear. Here's 3, here's 2. What's the area of that rectangle? 6 square units, right? You see them, right? 1, 2, 3, 4, 5, 6. 2 times 3 is, of course, 6. Now, I want to use a linear scale factor of 2. That's linear scale factor. That means I have to take each dimension and multiply by 2. So what does 3 become? So down here, 1, 2, 3, 4, 5, 6. And what does 2 become? 4. All right. 3 became 6, 2 became 4. How many units do I have now for area? All these would add up to 4 times 6, which is 24. So what has happened to the area? The original area was 6, and the new area is, divide those. 24 divided by 6 is 4. How does it relate to the original scale factor? It's squared. K squared is 4, the area scale factor. So why does that happen? Because you have to times this length by 2, and you have to times this length by 2. So in essence, you've times the whole thing by 4, which is 2 squared, right? What if the scale factor was 3? Then the area would be multiplied by 9, because 3 squared is 9. Okay, let's do this. Let's go 4 by 5 rectangle. Don't have to draw it, just write this. 4 by 5 rectangle. What's the area? 20. Let's triple. Let's say that the K value is 3. So what happens to 4? 4 becomes 12, and 5 becomes 15. 12 times 15, if you could pop that into your calculator. Twelve times 15 is 180. Okay, so new area over old area, 180 over 20. Divide those. 9. How does it relate? K squared is 9. So why does the area get scaled by 9? Because you had to times by 3 here, and you had to times by 3 here. So in essence, you've times by 9. And what would happen for volume? It wouldn't be squared, it'd be cubed. Question? Two squared is 4. So the new area divided by the old area should be 4, which is 2 squared. All right, let's go back to the book, which can often be confusing. Hopefully that little example there sort of simplified things for you. Okay, same question, but over onto part E here. So when we started the lesson, we were going to increase, back on me please, you're going to increase by 44%. This time we don't want to increase, we want to reduce by 25%. So start with 100%, because that's your original. And I want to reduce by 25. So I need to take away 25. And 75% has the decimal 0.75. So that's what we would multiply by. That kind of understanding is absolutely essential for life, not math. If you don't know how to do percents, life will be challenging. Okay? Especially if you go to a bank, or if you're trying to do a budget. Money is pretty much one of the most important things in life, and if you don't know percents, trust me, money is important. People always say money's not important and happiness is important. They're lying. Money doesn't buy you happiness? If you're not happy, and I gave you $1 million, you'd probably perk right up. Okay, relax. Okay, bring it back, bring it back, bring it back. Okay, bring it back, please, and thank you. Hi. I just wanted to talk about, just for a quick second, like 5% GST. You know, you go to 7-Eleven, you buy $1's worth of 5-cent candies. Your bill's $1, but what do you pay the cashier? $1.05. Okay, but if you did 1 times 5% as a decimal, you would get 5 cents. That's what you have to pay on top of the dollar. You can shortcut that by saying 1 multiplied by 1.05. This here, 1.05, is 100% plus the 5% tax. Does that make sense? Here, I want it to be 25% less, so I start at 1, and I take off 0.25, and I maintain 0.75. Okay? Hopefully that makes sense in terms of percents. So Maggie is going to do this reduction. So determine the dimensions of the print to the nearest 100th of an inch. So it was originally an 8 by 10. Do you guys agree? 8 by 10? And this 0.75 is my linear scale factor, which we call K. So I have to times each one of those by 0.75. So I'd go in here and multiply by 0.75 and multiply by 0.75, each one separately. I get 6, and then of course 7.5. You guys okay with that? Okay. Let's calculate those areas. 8 by 10 we know is 80. 6 by 7.5 times those, you get 45 square inch. Okay, do the new over the old. 45 over 80. 45 divided by 80 is 9/16 after using math fraction, because 0.5 would be 3/4. Look at the connection. 3 became 9 and 4 became from squaring. Okay, so there's lots of different ways to go at these problems. Well, there's 2 ways. You can do it linear or you can do it area. So choose your method, and if you know both, even better. This question is a bit ridiculous, only because the numbers suck. Okay? This question is only ridiculous because the numbers. Yeah. Oh, you want to get those notes? Which one?
Just in general, so you like.
How to get that fraction? Okay, 45 divide 80. Hit enter. Hit math. Hit enter twice. See it says fraction there? Yeah, beautiful. No worries. Are you question? Bathroom? Yeah, go. Olivia, you good? Okay. So this next question, it's a reasonable question except the numbers suck. So on a test, I'll look ahead at the test and I'll make sure that those numbers aren't ridiculous like that. And I'll make sure that the calculator will do it. You'll see here that the calculator has issues. So we'll go through this one. Okay, so you got a map of Alberta, and this is the actual, obviously, because it's in kilometers squared. And then he's got the map that he's making, and this would be the model. Okay, so you can just jot that in there. You got the model, the actual, the new and the old. All right, so then he wants, or the question wants, the scale of the map, and then in brackets, linear scale factor. So you're trying to solve for k. That's what they want. And it's going to be written in the form 1:x, and they just want x. They want x, nearest whole number. This is a ratio. It's a scale factor. And if you recall from yesterday, scale factors have no units because the units cancel. So for ratios, you need the same units. And if you look at us here, we got kilometer and we got centimeter. So that's an issue. So let's break this down using scale statement. And let's do, first of all, let's do statement for area. And you're just copying model first, actual second. It always goes like that. Model to original. It always is like this. Model to original or actual. I guess we can use actual. Model to actual or new to old. So it would be this 264.74. Include the unit. 661,850 km square. That's the statement. Hopefully you're comfortable with that. Now, the most logical thing would put this in a calculator and do the lowest terms fraction. But of course, they gave stupid numbers that don't work. Okay? Can you read those numbers to me, somebody? Thank you. Is that it? All right. You hit enter, you hit math fraction, and the calculator fails. It's just too small for the calculator. So, if you do it the other way, if you put the big number first, then you're not left with a really small number. You're left with a whole number, which is, oh, I typed it in wrong. I just typed it in wrong. It should be a 4. It should be a 4. Okay, so see how I got that? The 2,500? It's because I put the actual first and the model second. Then you can see what number they're talking about. That 4 to the minus 4 is 1 over 2,500. Let me bring this back. It's 1 centimeter square for every 2,500 kilometers square. So I just did some wizardry with the calculator. I will guarantee you that you will not have to do that sorcery. I will give you numbers that just work. Okay? This is a -2 class. It's supposed to be about real life. It's supposed to be about things that make sense. So I'm not going to try to confuse you. Is that because you did some stuff with the kilometer and the centimeter? Yeah, we'll get to that. Yeah, yeah. It's because of square units. Well, I'm going to talk about that right now. Okay. All right. So we have the scale statement for area. That's what we've been talking about. And it's right here. This is the scale statement for area. So what would the scale statement be for, and I'll just write down here, even though this is for question A, what would the statement be for length? I would have to take what I had for area and do this. Square root, square root. And you would get 1 centimeter for every 50 kilometers. That is the linear scale statement, not the scale factor. To get the scale factor, I need the same units. So then I would go to my data sheet, my blue sheet, and I would count the number of jumps from kilometer to centimeter. It's on that number line. How many jumps from kilometer to centimeter? 5 jumps. All right. So I'll convert the kilometers to centimeters. It just makes it larger. So I got to go 50 times 10 to the 5. You're just going to attach 5 zeros. 5 jumps. That's how metric works. Let me show you that on the calculator. 50 second function, comma, 5. Okay, so that's how you put in times 10 to. Is this second function, comma. That double E stands for enter exponent for scientific notation. Okay, so that number is 5 million. So it's 1 centimeter for every 5 million centimeters. Now, because that's a ratio, those units will cancel, and you now have the scale factor. 1 to 5 million. That's the scale factor. It's 5 million times smaller for the length. All right. Hopefully that was not too confusing. I wish they chose some simpler numbers. Now let's go ahead and do part B. Part B, they're going to tell you that with the same scale, same map, same scale, here is the model for the area. And this is where you have to be careful. It's for area, centimeters square. So I need to go and look at my statement for area. I'm just going to copy down that statement. 1 square centimeter for every 2,500 square kilometer. I was given this 376, so it goes over here because I was given square centimeter. And then over here is x kilometer, and now I can solve question B with a very simple cross multiply divide. You just take that 376.839 and times it by 2,500. Then I got 942. And it wants me to round nearest 100, so 942 100 kilometers. So question A is reasonable if the numbers are better. Question B is very doable. Question B, they gave you square centimeters, they gave you a scale statement, just cross multiply. Question B is very doable. Question A is only dumb because of numbers. So I'll stop up at the front and then I'll let you guys try the assignment. Okay? So if you want to skip number 1, that's okay in the assignment and just start at number 2. And if you get, there's only 8 questions. So if you get 2 to 8 done today in class, that's amazing. I'll get you the quiz shortly. Thank you for paying attention.